So in this video, we're going to continue looking at transformations, and we're going to look at how the value of k will actually transform an absolute value function. So at this point, you should understand the parent graph of an absolute value function. Here's your equation. It's the most basic absolute value graph. Then here is your table with the points plotted onto the graph. And then you have a domain of all real numbers and a range of y is greater than or equal to 0. So this is the graph that you should be familiar with. And what we're going to do here is we're going to add on and look at what happens when we add a value outside of the absolute value symbol. So when we take the absolute value of x and we add this value called k onto the outside. So here you'll notice we have our general absolute value graph of this absolute value of x. There's our parent graph back there in red. And what we're going to do here is we're going to change this slider for k. So k is currently set to be 0. Notice how k is a value added outside here, outside of the absolute value. And what we're going to do is we're going to change the value for k and see what happens. So I'm going to take my slider and I'm going to move it up. And what I notice, okay, k is 2. Look where the graph is. K is 3. Look where the graph is. K is 4. Look where the graph is. What I notice as I change k here, as I change this value on the outside of the absolute value, is as I make k a positive value, the graph continues to go up and it's at that value. So right here, k is at 6. The graph moved up 1, 2, 3, 4, 5, 6 units. So that's what I'm noticing as k becomes positive. Then as k becomes negative, so k is at -1. My graph has moved down to -1. K is at -2. The graph has moved down to -2. K moves down to -4. The graph moves down to -4. So what I'm noticing about this k value, or the value added on the outside of the absolute value, is that it actually moves the graph up and down when compared to the parent graph. So I'm going to go back here, and I'm actually going to summarize this. So if I want to make a note here, I'm going to make a note that k is called the vertical shift. So make a note of that, maybe in a different color for yourself. So k is known as the vertical shift. It's how the graph moves up and down. So that's the first piece we need to know. Then we're going to summarize what happens when k is positive compared to when k is negative. So I'm going to add that piece in. When k is positive, the graph shifts vertically up that many units. So if k is, let's say, 4, the graph moves up 4 units compared to the parent graph. And we saw that back here. When I changed k to be 4, the graph moved up 4 units. Simple as that. Then here, if I summarize when k is negative, when k is negative, we note that the graph shifts vertically down that many units. So essentially, if k is -4, the graph moves down 4 units compared to the parent graph. So if we go back to Desmos here, notice if we change k to a -4, it moves down 4 units when compared to that parent graph in red. So our k value is our vertical shift, and it actually shows us how our graph is going to move vertically when compared to the parent graph. So here I have 2 equations for us to look at. For each equation, we're going to describe how the parent graph was altered to create these children graphs here. So here we see y equals absolute value of k plus 4. And what I notice about this is I notice k is equal to 4. I know k is a vertical shift, so I know that the graph is going to move up 4 units when compared to the parent graph, because k is a positive value. Then here in this next one, I can see that k is equal to -3. -3. And what that tells me is the graph is going to move down 4 units when compared to the parent graph. So we can clearly see when K is going to move up and when K is going to move down just based on that value being positive or negative.